Chapter 4, calculating a mean absolute deviation. On slide 13 in Chapter 4, you see that a mean absolute deviation, or MAD, is a mean of errors that are made over a time period without the basis of under or overestimating. And the formula for MAD is the sum of the actual forecast for a time period minus the forecasted demand for a time period divided by n, which is the number of time periods we're looking at. So we're going to be using that formula when we take a look at MAD. So calculating here, we have our actual demand A, our forecasted demand F, and we want to find the deviation of that, A minus F. And literally that is just taking our demand minus the forecasted demand. So 120 minus 125 is a negative 5. Or 130 minus 125 is a positive 5. 110 minus 125 is a negative 15. 140 minus 125 is a positive 15. 110 minus 125 is a negative 15. And 130 minus 125 is a positive 5. Now, if you notice, we actually took a look at time periods. Everything we worked with was in the same time period, and there were 6 separate time periods. So to calculate the MAD, remember we said that our MAD is the sum of the absolute value of A minus F, both in the same time period, divided by N. So what we want to do is we want to find out what the absolute deviation is. And an absolute deviation is the number of clicks on a timeline, not taking into account whether you're moving right or left in a positive or a negative fashion, but just how many points away. So we literally remove the sign and have just the number there. So the absolute deviation of a negative 5 is 5. The absolute deviation A minus F of positive 5 is also 5. For the negative 15 would be 15. For the positive 15 would be 15. Negative 15 again would be 15. And the positive 5 would be 5. We removed the positive or negative sign to find that absolute deviation. We now want to sum these up because the top the numerator of our formula is the sum of A minus F. So if we add these up, you've got 5, 10, 15, 20, 25, 30, 40, 50, 60. So the sum would be 60, and that would be our numerator. The N, we said, was the number of time periods. And I counted these out onto the side where I put the T, the 1 through 6. We have 6 time periods here. So it would be 60 divided by 6, which is 10. Now, in and of itself, that 10 means absolutely nothing. It is a comparison mode, and the smaller the deviation, which means the less your forecast is away from the actual demand, the better the MAD is. So if you had a MAD of 3 versus this MAD of 10, that other way of forecasting would be mimicking what the actual demand is much better. So that would be a better MAD score, or mean absolute deviation score. But you have to compare one MAD to a different MAD using 2 different forecasting methods. That is looking at the calculations of mean absolute deviation, or MAD. And we are now going to move on to mean squared error. Mean squared error literally weights or penalizes large errors in forecasting. And it is found by summing up the actual minus the forecasted for each time period and squaring that and divide by n. And that right there is slide 16 in chapter 4. So if we go to calculate our mean squared error, we're using the same information we had before. And we're going to take our 6 time periods again. We've already figured out the deviations. A minus f as a negative 5, 5, negative 15, 15, negative 15, and 5 from our different time periods, and we now need to square that. Now, a negative times a negative is a positive, and I know that seems silly for me to remind you of that, but it's what I call a dummy check. I am squaring my negative 5. So negative 5 times negative 5 is actually 25, and I just want to double check myself that I didn't mistakenly put the negative sign there, that I did do it correctly. 5 times 5 is 25. 15 times, or excuse me, negative 15 times negative 15 is 225, and 15 times 15 is 225. I have negative 15 again, which is 225, and 5 squared is 25. Again, our mean squared error is found by summing the actual minus the forecasted in each time period, squaring them, divided by n. So I want to sum this up. So doing it quickly in my head, 1, 2, 3, 4 25s is 100, 2, 3, 4, 5, 6, 7. With 2 25s left over, I've got 750. Always check my math. So my numerator here is 750. Again, I had 6 time periods. So my MSE is 125. Again, the MSE cannot just be taken on its own. It is a comparative number. You're either going to compare it to an industry standard, or you're going to compare it to another MSE, mean squared error, found by a different forecasting method. Here we have 125. If the other MSE that we had was 182, this MSE, being a lower number, would be the better mean squared error, and therefore the forecasting method would be doing a better job. So that is our mean squared error.